As the saying goes, nothing comes from nothing. Now let's apply this concept to the vast expanse of the cosmos, leading to an intriguing question. How did the universe truly originate from absolute nothingness? In our everyday lives, we understand that something can only take shape when the necessary components exist for its creation. But when it comes to the birth of the cosmos, the moment of the Big Bang, where did the raw material originate? Today, we embark on a journey to delve deeper into this profound subject. We'll explore what experts have to say about this fundamental inquiry and whether our current knowledge allows us to provide a definitive answer. Join us as we search for clues together. Are you eager to uncover the groundbreaking discoveries and profound mysteries of the universe? If so, make sure to subscribe to Cosmos Prodigy and activate the notification bell for regular updates on these fascinating topics. Show your support with a thumbs up, letting us know that you're excited to explore the content in our videos. The end as the beginning. Whether we contemplate the Big Rip, the Big Crunch, or the Big Freeze, these cosmological theories, despite their differences, all converge on the same outcome: the eventual demise of the universe. According to these hypotheses, there will come a day when the last star and the entire cosmos will burn out. The universe will transform into a lightless void where colossal black holes like dark predators will consume the remaining matter before ultimately evaporating, culminating in a final act of destruction. Space will expand to the point where even the faint glimmer from these evaporating gravitational behemoths will scatter into nothingness, and the cosmic symphony will reach a complete standstill. This perspective is widely shared among scientists, depicting the ultimate fate of our galactic abode. However, amidst this vision of cosmic dissolution, some experts perceive an entirely different perspective, the inception of a new universe. They posit that it was precisely such a dark, frigid, and desolate universe that served as the canvas for the Big Bang. But before we delve deeper into this intriguing hypothesis, there's another equally riveting question we must address: the origin of the first physical matter. When we endeavor to elucidate how stable matter emerged from atoms and molecules, we encounter the challenge that neither such matter nor conditions existed during the Big Bang or the ensuing millennia. What we do comprehend is that the first atoms materialized from simpler particles once external conditions cooled sufficiently to permit the formation of complex, enduring matter. We also comprehend the subsequent fusion of these atoms within stars, birthing heavy elements. However, our current knowledge leaves us devoid of insights into the enigma of creation ex nihilo, something arising from nothing. Let us rewind the cosmic wheel of time even further. Protons and neutrons, the building blocks of atomic nuclei, are considered the initial enduring matter particles in the annals of the galaxy. It is generally assumed that they emerged shortly after the Big Bang. Nonetheless, in the classical sense, no tangible matter existed before that pivotal moment. Thankfully, the realm of physics enables us to trace the chronology back to preceding events, which transpired before the birth of stable matter. The Planck era. Within physics, that era is called the Grand Unified Theory. In detail, this theory is based on the fact that at the time of the Big Bang, 3 of the 4 known basic physical forces, namely the strong, the weak, and the electromagnetic interaction, existed in the form of a single unified force. If we penetrate even deeper into this area of speculative physics, we see that the physical world consisted of a kind of hodgepodge of short-lived elementary particles. Among them were quarks, the building blocks of protons and electrons. The relationship between matter and antimatter was balanced. Each type of matter particle had an almost mirror image counterpart made of antimatter. If these two particles, which differ from each other, only in one aspect ever met, they would destroy each other. But how are these particles formed? In this respect, the quantum field theory says that even a vacuum, considered the prime example of an empty space, is in reality bristling with physical activity. This occurs in the form of energy fluctuations and can cause particles to appear only to disappear again. Consequently, the vacuum of space-time is also characterized by such processes. Here, the particles seem to appear out of the proverbial void. If we stretch our central question further, we come to another obstacle. How then did space-time come into existence? In this respect, the Planck era impressively demonstrates to us that we eventually come up against insurmountable barriers with our physical theories. In detail, the conceivably short-lived Planck epoch covers the immediate period after the Big Bang. At this point, space and time themselves became part of quantum fluctuations. We need a complete theory of quantum gravity that unifies quantum physics with relativity and theory, and loop quantum gravity are considered promising candidates in this regard. Here, ordinary space and time are commonly regarded as emergent. Consequently, what we perceive as space and time is, in fact, the result of quantum processes occurring at a microscopic level that is incomprehensible to us. Since our common understanding of space and time is no longer valid in the Planck era, our classical conception of cause and effect also reaches its limits. Nevertheless, all the theories devoted to this section describes something physical that was happening at that time, a kind of quantum precursor of space and time. Even if our understanding of causality does not apply in the Planck era, it might be theoretically possible to fathom one component of that era with the help of another. However, our current theories are not capable of handling this challenging endeavor before the corresponding doctrines are fully developed. We cannot make any generally valid statements about the central formation processes of the cosmos. At present, it remains to be stated that physicists don't know any confirmed cases in which something has formed from nothing. Creator, multiverse, or cycles. Currently, our ability to decipher the quantum state of the universe during the Planck era remains an insurmountable challenge. Consequently, all theories in this realm remain highly speculative. Some have attempted to elucidate this central enigma by invoking the influence of a divine creator. Alternatively, less religious interpretations favor the concept of a multiverse as a promising approach. According to this theory, the cosmos isn't an all-encompassing entity, but rather a minuscule link in an infinite chain of other universes. On a different front, there are cyclic models that propose a perpetual cycle of destruction and rebirth for the universe. Notably, Nobel Prize winner Roger Penrose, a distinguished British physicist, championed the theory of conformal cyclic cosmology. According to Penrose's elucidation, intriguing mathematical parallels exist between the Big Bang and the distant endpoint of the universe. In fact, these two states become identical when taken to their extremes. This intriguing circumstance led Penrose to a paradoxical hypothesis. The absence of matter, the closest approximation to nothingness, gave rise to all matter in the cosmos. From this vantage point, the Big Bang originates from what remains when the matter of a universe has been annihilated by black holes that subsequently decay into photons. But how can a cold, empty universe be mathematically equivalent to a hot, dense universe? The answer to this puzzle lies in a sophisticated mathematical technique known as conformal scaling. This geometric transformation alters the size of an object while preserving its fundamental shape. Remarkably, through conformal scaling, it becomes possible to align the states of the universe in such a way that their space-time shapes coincide. In essence, the hot, dense state emerges as a consequence of the cold, empty state, implying that the end of an expanding cosmos ultimately ushers in a new Big Bang. The search for the nothing. Let's imagine that one day Penrose's controversial theory is indeed validated. Even in such a scenario, we would still be left pondering the age-old question: how can something emerge from nothing? Where does the foundation of physical reality originate? How does the intricate cycle system of the universe come into being? Why does existence exist at all rather than nothingness? Can there truly be such a concept as absolute nothingness, defined as the absence of everything? If so, how can something exist that essentially does not exist? As we delve into this captivating topic for today's video, it doesn't take long before we find ourselves confronting profound philosophical inquiries. However, for now, let's remain within the realm of physics. So, what insights does science offer regarding the potential underpinnings of these cosmic cycles? One perspective suggests that there may be no physical explanation at all, or it could be an unceasing succession of recurring cycles where the initial quantum state of each cosmos sets the stage for the properties of the subsequent universe. Moreover, it's conceivable that only a single cycle exists, with the initiation of the cosmic cycle determined by an attribute of its eventual conclusion. Whether we will ever obtain definitive answers to these fundamental questions about the universe remains uncertain. Yet, it's precisely this profound uncertainty that renders the subject so compelling. Time and again, researchers direct their gaze toward the farthest reaches of space in pursuit of fresh insights into our galactic surroundings. Nonetheless, the exploration of remote cosmic domains isn't always necessary, as sometimes they come to us. Case in point, smaller celestial objects routinely enter Earth's atmosphere, offering valuable insights into themselves and their origins. A noteworthy event of this nature, while not uncommon, is believed to have occurred in Papua New Guinea a few years ago. The intriguing aspect of this incident lies in the fact that this discovery remained concealed from the global audience for some time. The Secret Meteor. The year is 2014, when the sky over Papua New Guinea briefly begins to glow. At that time, on January 8th, an object entered the Earth's atmosphere at an insane speed and subsequently burned up. Before that, the cosmic projectile had moved through space at a speed of more than 120,000 miles per hour. A really impressive speed, clearly exceeding the average speed of classic meteorites spinning past our domestic solar system. It was this extraordinary speed that provided the experts with a revealing insight into the origin of the meteorite. In the study conducted in 2019, experts concluded that the compact meteor just under 2 feet in diameter was 99% likely to have originated outside the solar system. It was possibly a structure that came from the deepest reaches of an alien planetary system. There's a thesis that the meteor originated in the dense disk of the Milky Way. Despite these remarkable findings and theories, however, the results of the scientific study were meticulously kept under wraps for a long time. The fact that we are only now learning about this exciting discovery is primarily due to the fact that some of the data needed to verify the calculations were classified as top secret by the U.S. government. Since the interstellar trajectory of the object is now considered confirmed, it retroactively advances to become the first interstellar structure ever detected in our solar system. This title previously belonged to the object Oumuamua, which has posed great mysteries to researchers since its discovery in October 2017, but more on that later. Amir Siraj, a theoretical astrophysicist at the renowned Harvard University and lead author of the study, now intends to publish the results of his work in a timely manner. This will make it possible for the international scientific community to extend the analyses. Since the meteor burned up over the South Pacific at the time, it's conceivable that some of its fragments landed in the sea. It's therefore possible that some fragments of the galactic projectiles still lie dormant at the bottom of the ocean, waiting to be tracked down and studied. Although recovering this interstellar debris is like the proverbial search for a needle in a haystack, Siraj is already in intensive talks with other experts to discuss just such an expedition. Flying mystery. Before the true origins of the 2014 meteor were uncovered, Oumuamua was celebrated as the first object observed within our solar system to be classified as interstellar. This remarkable discovery was made possible through the Pan-STARRS telescope located in Hawaii, and it was officially added to our celestial maps on October 19, 2017. However, by the time astronomers became aware of this peculiar entity, it had already embarked on its journey back into interstellar space. Astronomers typically define interstellar objects as bodies located in the vast expanse of space far from any star, devoid of gravitational ties to a particular parent star. These objects may transiently pass near a star during their voyage through space. Upon learning of the existence of our interstellar visitor, a fundamental question arose. What precisely is Oumuamua? Initial analyses of its orbital properties pointed toward a conventional comet. However, this initial hypothesis was swiftly called into question because Oumuamua lacked the characteristic tail associated with comets. What we do know is that the object reached the pinnacle of its orbit on September 9, 2017. At that moment, it was hurtling around the sun at a staggering speed of over 50 miles per second, coming within approximately 20 million miles of our central star. A little over a month later, Oumuamua passed by Earth, coming closest at a distance of about 15 million miles. Since then, this interstellar wanderer has been on a course toward the constellation Pegasus. In addition to these established facts about its trajectory, there were also perplexing observations that scientists have yet to fully explain. One of these mysteries is the observation that Oumuamua didn't slow down as much as expected after its solar encounter. Pure gravitational effects couldn't account for this phenomenon. Initially, it was speculated that this additional acceleration might result from the outgassing of volatile components, which typically leads to changes in rotation. However, no such rotation change was detected. To gain deeper insights into the characteristics of this enigmatic object, numerous modern telescopes were employed to observe Oumuamua. During these analyses, it became apparent that the object exhibited dramatic fluctuations in brightness, suggesting an elongated cigar-like shape. Nevertheless, the analysis of photometric data couldn't fully account for the unusually intense brightness fluctuations in relation to its rotation speed. Consequently, it appears that Oumuamua doesn't rotate along one of its principal axes during its journey. Instead, it seems to tumble through space. All these unexpected observations and characteristics have led to a central question. Could it be possible that Oumuamua has no natural origin and was, in fact, artificially created? An alien spacecraft? This controversial speculation was also fueled by the fact that no dust particles could be identified in the immediate vicinity of the ominous body. This in turn leads to the assumption that Oumuamua does not contain any water and possibly consists entirely of metal. Since the surface of the object was exposed to an incessant bombardment of cosmic rays during its billion-year journey, the experts assume a comparatively low reflectivity. Assuming that the albedo is 0.04, the mean diameter of the missile would be about 700 feet. In November 2018, astrophysicist Avi Loeb and Shmuel Bial hit the headlines when they tried to justify the absence of dust and orbital deviation with an unconventional hypothesis. Thus, the corresponding observations could well be explained by an extremely thin, large surface area, a body that was deflected from its ancestral orbit under the influence of the sun's radiation pressure. Possibly, so the two Israeli experts think Oumuamua is an extraterrestrial solar sail sent by an intelligent civilization to research our solar system. An unusual assumption which was not categorically rejected by other researchers. In fact, in December 2017, some researchers decided to take a closer look at Oumuamua as part of the Breakthrough Listen research project. To this end, the entity was analyzed by the radio telescope at the Green Bank Observatory in West Virginia. The goal of this endeavor was to register possible signals of artificial origin, although it was considered extremely unlikely that we'd encounter radio signatures of an extraterrestrial species in the run-up to the work. The scientists nevertheless saw the investigation of Oumuamua as a worthwhile, unique opportunity. Over a period of 14 days, the interstellar object was analyzed in different frequency ranges. However, the evaluation brought the sobering realization that no evidence of an artificial background could be found. Future investigations. To reveal the true background of our mysterious visitor, a direct investigation seems most promising. But how do you intercept a craft traveling away from us at more than 15 miles per second? It would be virtually impossible for conventional space probes to reach Oumuamua. In order to get to the bottom of this exciting mystery one day, new approaches would have to be taken. One such concept is based on a literally explosive approach. An unmanned spacecraft could be ejected from our solar system by igniting a solid fuel engine. Once such technology is fully developed, it would be possible to reach Oumuamua within 16 years of the launch of the terrestrial spacecraft. However, patience will be required before this can happen. Those who do not believe in an artificial origin of the object sometimes suspect that it could be the fragments of a Pluto-like exoplanet. According to this view, Oumuamua would consist mainly of frozen nitrogen. However, the interstellar structure would have already lost most of its original mass. During its journey, large parts of the nitrogen ice melted so that the once clearly more massive body took on a flat form. Black holes are not only one of the most impressive, but also one of the most puzzling entities the cosmos has to offer. While experts have successfully deciphered many of the fundamental characteristics of these gravity monsters, in recent years, one question has remained unanswered. How are supermassive black holes formed? While we now know that the particularly large representatives of this class of objects grace the centers of nearly all galaxies, how they themselves are created is still a galactic mystery. A breathtaking discovery could, however, bring some light into the cosmic darkness. For the first time, researchers have tracked down the precursor of a supermassive black hole. In today's video, you'll find out what this sensational discovery is all about and what puzzles still need to be solved in the future. Mysterious omnivores. Whether it's matter, radiation, or any form of information, everything ensnared by the grasp of a black hole becomes irretrievably lost. This fundamental characteristic stipulates that once something crosses the event horizon of a black hole, it can never escape. It's an awe-inspiring yet daunting property, stemming from the incredibly potent gravitational force exerted by these cosmic giants. This gravitational force arises from the extreme compactness of black holes. To put it into perspective, if a black hole were to possess the same mass as our Earth, it would occupy a space not much larger than a speck of dust. However, when we survey the astronomical reality, we find that these gravitational behemoths far exceed the mass of our home planet. In fact, within the vast cosmos, there exist black holes that dwarf our sun's mass by factors of millions or even billions. However, it's crucial to note that not all black holes are created equal. The mechanisms governing what are known as stellar black holes are relatively straightforward. As the name implies, these objects originate from stars. When a star of sufficient size reaches the final stage of its life cycle, it undergoes a supernova, shedding its outer layers. What remains is the stellar core, which succumbs to its own gravitational pressure, collapsing into an incredibly compact structure, forming a stellar black hole. As mentioned earlier, black holes consume everything that crosses their galactic paths, leading one to assume that these cosmic giants obliterate anything within a certain radius of them. However, the reality is quite the opposite. It is now widely accepted that supermassive black holes play pivotal roles in the evolution of galaxies. Beyond their event horizons, these gravitational powerhouses behave much like conventional massive objects. Consequently, it's entirely possible for other celestial bodies to maintain stable orbits around supermassive black holes. A groundbreaking discovery. Unfortunately, what is true for stellar black holes does not translate seamlessly to their supermassive counterparts. While experts can trace the formation of stellar black holes in detail, the birth of their significantly more massive counterparts has always resembled a formidable mystery. To get one step closer to solving this cosmic mystery, data and observations are needed above all. And in fact, astronomers recently scored a bullseye in this regard with the scientific designation GNZ7Q. Experts suspect that the detected object could indeed be the precursor of a supermassive black hole. In detail, the sensational discovery was recorded in a galaxy from the early days of the universe and possibly represents the missing piece of the puzzle within the star-forming galaxies and the first supermassive black holes of the cosmos. Observations in the ultraviolet and infrared spectra showed that a black hole is growing inside the galaxy under study. Until now, the most distant objects were either so-called starburst galaxies, known for their enormous star formation rate, or galaxies with incredibly active supermassive black holes that outshine the light of all surrounding stars, so-called quasars. In the case of GNZ7Q, at first glance it appears to be a classic starburst galaxy. However, the information gathered during the in-depth investigation suggests that the central black hole is in the process of transforming into a quasar. In this regard, analysis of the object across the electromagnetic spectrum is in exact agreement with predictions from theoretical simulations. In detail, the corresponding galaxy produces about 1,600 sun-like stars per year, exceeding the corresponding formation rate of our local Milky Way galaxy many times over. The emitted UV light matches the characteristic accretion disk that typically surrounds a supermassive black hole. However, no X-ray emission has yet been detected in the central regions. This circumstance suggests the conclusion that the future supermassive black hole is currently still completely enveloped in gas and dust. Such a scenario has so far only been predicted in computer simulations, never directly observed. Accordingly, GNZ-7Q is considered a promising candidate when it comes to the question of the missing link between starburst galaxies and quasars. Astronomers plan to study the structure in the future using the James Webb Space Telescope. If everything goes according to plan, the complex instrument will begin its scientific service in a few months and provide us with a previously unknown insight into the greatest mysteries of the cosmos. What do you think about these theories? Let us know your thoughts in the comments.